If an IT network is breached, a company might lose data or expose credit card numbers. But if an operational technology, or OT, network is compromised, the damage leaves the screen. It shuts down a power plant. It halts an oil refinery. It stops water treatment for an entire city. Most cybersecurity professionals are trained to secure data. They focus on patching software and isolating networks. However, applying these standard IT methods to delicate physical processes often breaks the very systems they are meant to protect. To bridge that gap, the industry relies on IEC 62443. This is an internationally recognized series of standards built specifically to secure industrial automation and control systems. In an industrial setting, a security failure results in physical damage, ruined equipment, halted production lines, and immediate safety risks to personnel. This diagram shows the classic CIA triad. In traditional IT, confidentiality is the heaviest weight on the scale. But in industrial environments, the math flips. Availability becomes the primary concern. Continuous operation is required. Unplanned downtime can cost millions. Human safety is tied directly to this availability. A compromised programmable logic controller manipulates heavy machinery in the physical world. You are tasked with protecting these priorities on systems running legacy software, designed decades before modern malware existed. This flowchart maps a response scenario. If you detect malware on a controller managing high-pressure water valves, consider your first move. Quarantining immediately locks the valve, building pressure until a pipe bursts. The correct action is assessing safety impact first. Applying standard IT security responses to OT environments can transform a digital incident into a physical disaster. This diagram shows the structure of IEC 62443, divided into 4 interconnected parts. Part 1 acts as the dictionary. It establishes the foundational concepts, terminology, and baseline security models needed to understand the rest of the framework. Part 2 is the policy layer, written for the facility manager, outlining requirements for risk assessment and incident response. Part 3 provides system-level requirements, guiding network integrators on how to build secure zones and conduits. Part 4 focuses on the components. It sets the strict development practices required from the vendors who manufacture the hardware and software. These 4 parts lock together, creating a continuous chain of accountability. It links the vendor building the sensor to the owner operating the entire plant. This progress bar maps out our next 100 days. You don't need to memorize the entire framework right now. We will move through it systematically. We will move through 4 specific phases, starting with foundations, taking a deep dive into core standards, moving into practical implementation, and finally applying it all with real-world application. This reference sheet summarizes today's key points. It contrasts the differing priorities between IT and OT and breaks down the core structure of IEC 62443. Committing to this standard over the next 100 days equips you with a specialized skill set. It moves you beyond standard network administration and provides the tools needed to protect the physical infrastructure the world relies on.